Hi, this video to demonstrate my project. My project is a car park where it has a screen that welcoming the guest and showing how many available slots inside the car park. In each floor, we're gonna have a 7-segment display to show how many slots available in that floor. When a guest is entering a floor, he can see a red and green LEDs where he can find which one is occupied and which one is not, and easily find a slot to park his car. We're gonna go on each part of my project, so let's go. This is a continuing of my demonstration for my project. Now I'm going to talk to you about the cloud part of my project. As you can see, there is 3 cars are parked in my car park with red light above it. All the data is gathered by the obstacle avoidance sensors inside there, and then going to the Raspberry Pi, and then go to the particle photon through I2C. The particle photon will publish all this data onto the website, as you can see here, with each slot showing either 1 or 0. Slot 1 means like there is car is parked in this slot, or 0 means like there is no car is parked there. As you can see, slot number 2 is showing 0 at the moment. So if we go back and we park one of the cars and move again, in a second, we will see that the slot number 2 now move from 0 and will change to 1. Here it is. So slot number 2 is moved now to 1. If we move to parked car, also, as you can see, the number of cars has been changed from 3 to 4 because there is a car has been parked in slot number 2. We'll start with the first part of my project, which is a gate. The gate consists of one IR beam brake sensor and servo motors. So when a car is getting between the IR brake beam sensor, it sends a signal to the Raspberry Pi where it says this car exists here. So the Raspberry Pi then sends a signal to the servo motor saying open the gate. Servo motor is opening the gate by changing the duty cycle to change the gate from a specific angle to another angle. Once the car has passed the IR brake beam sensors, another signal is sent to the Raspberry Pi saying the car is already passed. So the Raspberry Pi is sending another signal to the servo motor saying change your duty cycle back again to change the angle of the gate from open to close. So now, if I move the car now in between the IR brake beam sensors, the gate is open and it will not close because it's still existing between the IR brake beam. And once it's past the brake beam, the gate is closed. So when a car is coming, it's opening the gate, and when it's passed, it's close the gate. This is exactly the same as exit enter. I'm using another IR brake beam sensor and also another servo motor.
Now we're going to start with the coding. Let us look at the coding for the servo motor for the entry gate. So I make a Python code as entry.py. First, we start with importing the library of rpi.gpio as GPIO and import the time library. I set the warnings for the GPIO as false and the set mode for the GPIO as BCM. That is the naming, how we name the GPIO. There is 2 options, either BCM or board. Board is just numbering of 1, 2, 3, 4 by the location of the pins on the Raspberry Pi. BCM is a GPIO naming that you can get if you Google BCM naming of the GPIOs. Entry gate is connected to GPIO 26 and entry sensor is connected with GPIO 22nd. We first set up the entry gate as a GPIO out, and we set up the entry sensor as GPIO in with pull up down as GPIO, pull up down as up. Next, we define two functions, close gate and open gate. The close gate, we start with making an object of B for the BWM, for the entry gate with frequency of 50. Then we start this object, start with a BWM with 0. Closing gate is working by changing the angle of the servo motor. So we are changing the angle of servo motor by changing the duty cycle. So we first start with the B dot change duty cycle 12.8, sleep for 1 second, and then change duty cycle to 8.9, sleep for 1 second. That is a changing of the servo motor angle when we call this function, and then B dot stop. We're going to do the same with open gate, except only the value of the duty cycle change, because we're going to go from close to open. We're going to declare an object of B with BWM, for BWM with entry gate with frequency 50. Then we start at 0, change duty cycle from 8.9, sleep for 1 second, and then change duty cycle to 12.8, and then we sleep for 1 second and then stop. I declare another function here called start entry module. I declare a variable called getState as close, and then make a loop. So if the entry sensor is showing an input of 0, this means like a car is between the IR beam brake sensor, and the getState is close. So and the gate in front of the car is closed. Then what we're going to do, we're going to call the function of open gate. So it will gonna change from close to open, and then we declare the variable getState as open. If the car has been moved, so the entry sensor will get an input of 1, and if the getState is open, so we need to call the function of close gate, so it's going from open to close, and we declare the variable getState, change the variable of getState as close. I hope this helped with the entry gate coding information. See you with the next code.
Now we move to the exit gate. It's working exactly as the entry gate. So when the car is approaching the sensor and brake the beam, the gate will open, and once it's gone out, the gate is closed. Thank you.
Now we move to the exit gate. The coding for exit gate is kind of the same as the entry gate, except only the entry gate and the entry sensor GPIO numbers are different. So we start with importing the library of RBI.GPIO as GPIO, importing the time library, then set warnings for the GPIO as false. We set the mode for the GPIO as BCM. As we discussed, we have two naming for GPIO. One is board and one is BCM. I'm going to use a BCM. The entry gate is connected with the GPIO 19, and the entry sensor is connected with GPIO 14. We set up the entry gate as GPIO out, and we set up the entry sensor as GPIO in, with pull up down as GPIO pull up down up. We are calling two functions, close gate and open gate. For pulse, we are declaring, making an object of BWM for entry gate with frequency is 50, and then we start the BWM. The angle of the gate is declared by changing of the duty cycle of the servo motor. So we start BWM, B dot change duty cycle from 8.9, sleep for 1 second, and then B dot change duty cycle to 4. That is the angles where it starts and where it ends, and then we stop the BWM. The same for open gate. We are make an object of B for BWM for entry gate with frequency of 50, and then we start the BWM. We change the duty cycle for BWM from 4, sleep for 1 second, and then change duty cycle to 8.9, sleep for 1 second. That is where it starts and where it ends, and then we're gonna stop the BWM. We declare another function called start exit module with get state as close, and then we make a loop. We're going to get entry sensor of 0 when the car is in between the IR big beam sensor. If that's happened and the gate state is close, we're going to call the function of the open gate in order to open the gate for the car, and we change the variable of get state to open. Vice versa, if the entry sensor is showing 1, which means like the car has passed this IR big frame, it will give input of 1, and the gate state is open. What we're going to do, we're going to close the gate. So we're going to call the function of close gate, and we change the variable of gate state as close. I hope this is making sense for the coding for the exit part of the project.
This part of the project is about the LCD screen and the 7-segment display. The LCD screen, I'm using a library in order to for the Raspberry Pi to send a specific words to the first and the second line of the LCD. The LCD is welcoming the guest when he is entering the car park and showing how many available in the car park slots. The 7-segment display is updating once there is a car has been parked or unparked from a car slot. When it shows 0, it means like there is no car space, and if there is any car space, it will update to show the numbers of car space available. So as you can see now, the LCD screen is showing no space and full. That means there is no spaces inside the car park, and the 7-segment display is showing 0. If I take one car out of the car park, now the LCD screen is showing 1 space available, and the LCD screen is showing 1 space available, and the 7-segment display is showing 1 to show in this floor there is 1 car space available. Now we went to the first floor. The first floor consists of 5 car park slots. They are working on multi-threading, so each car slot is working with the others in a parallel way. I'm using obstacle avoidance sensor for each car park slot. When a car is entering the car park slot, the sensor is within the range of this obstacle avoidance sensor. The obstacle avoidance sensor is sending a signal to the Raspberry Pi, and then Raspberry Pi is sending a signal to the green and LED above it. The green LED will go into low, so turning off, and the red LED will turn on by going high. At the same time, the 7-segment display will update how many car space is available, and the outside LCD screen also will update how many spaces now being available. So let us see what's gonna happen. So this orange park is approaching the sensor. Now the sensor is sending a signal to the Raspberry Pi, and the Raspberry Pi changing the green into low and the red into high. And as you can see, the 7-segment display also showing 0 now because there is no car space. And outside, welcome to Zaki Car Park, and then available, or sorry, that will say there is no space available. As you can see, no space and full. If I get this car out back again, the car slot become available, the green is showing, and now the 7-segment display is showing 1, and the LCD will show there is 1 car slot available at the moment. So it's show available now, and 1 space is available. This car park is working in multi-threading mode, so the 5 car park slots is working parallel. So if I get 2 cars out at the same time, as you can see, the car park display is showing 2, and the slot become available, and outside it will update the screen as well to show there is 2 car slots available, 2 spaces. Now let us move to the next part of my project.
Now we're going to look at the code for the car park slots. First, we're importing the threading to make a multiple threads which working parallel to each other. We are importing RPI.GPIO as GPIO, importing the time library, import numbers display. This number display is for the 7-segment display, which showing the numbers of the available car park slots. Import rasp_I2C_photon. That is the library that I'm using for like sending a data from Raspberry Pi to Particle Photon. Then we get the set. We're going to do a set warnings as false, and we set the mode for the GPIO as PCM. As we discussed before, PCM and board is a different kind of name for the GPIO on Raspberry Pi. We declaring 5 variables for the different car park slots. The slot 1 is connected with GPIO number 6. Slot 2 is connected with GPIO number 20. Slot 3 is connected with number 16. Slot 4 is connected with GPIO 12. And slot 5 is connected with GPIO 21. The LEDs in above each car slot also connected to different GPIO. So slot 1 green is connected to GPIO number 9, and slot 1 red is connected with GPIO number 11, etc. till GPIO number 18 for the red LED for slot number 5. We're declaring variable called slot 1 state as 0, slot 2 state as 0. That is as a state of each car park slots. We start with 0, as if there is no park car in these slots. And we declare a variable for slots as 5 and parked cars are 0. We set up all the GPIO for slots that's connected with avoidance, obstacle avoidance sensors as GPIO in, with pull up down as GPIO.pull up down up. And then we set up the LEDs, all the LEDs as GPIO out, either red or green for the different slots. We're declaring a function called parked car calculation. That is for calculating how many cars are parked in the car park. We're declaring each slot state as global, and we calculate the parked car as adding the 5 car slots. This gives us a parked cars, and we can print the parked cars. The next function is update displays numbers. So we have slots variable and we have parked variable. We minus the slots minus parked cars to get the available cars, and then we call the function is show available in the numbers display library. The next function is slot 1. So we have a slot 1 state variable as global, and then we're making a loop. So if the slot number 1 is giving us an input of 0 and slot 1 state is equal to 0, what does it mean? It means like the obstacle avoidance has getting a car in front of it. So we're going to and it was the state of this slot was 0 before. So we're going to change the slot state to 1, which means like there is a car there, and then we going to calculate the numbers of the car park to update the number of parked cars, and we're going to update the display number, which is showing on the 7-segment display. And we're going to change the which LED is working above it. So we're going to give slot 1 green to be low, so turning off the green LED, and we're turning the red LED is on. And we sleep for 1 second and we print Park 1 is occupied now. Vice versa, if a slot 1 is showing, if giving input of 1 and slot 1 state was 1, what does it mean? It means like the car has left the car park, so the obstacle avoidance sensor is not sensing it anymore. And the slot 1 state, it was 1. We change the slot state to 0. And we calculate the parked car by calling the function of parked cars calculation, update the display number, and then we switch back again the between the green and LED. So we put the green LED above the car slot to high, so turning it on, and putting the slot 1 red, the red LED above it, to low, and sleep for 1 second and print Park 1 is empty. We're doing exactly the same of this function with each car park slot, as you can see, exactly the same. So if any sensor, like obstacle avoidance sensor, has getting an input of 0, this means like a car has been parked and the slot state was 0. We change the slot state to 1, which means like it now occupied, and then we calculate how many cars are parked and update the display number, and we switch the LEDs above the car slot between green to be turned off and red to turn on, and then sleep for 1 second and print this car slot is occupied. And the other way around, if the slot was having a car before and now we're getting input of 1, which means the car has left already, and the slot state was 1 before, we're changing the slot state to 0. We calculate the car which is parked, update the display number, and change the green to be high, which putting the green to be on, and we change the red to low, which turning it off, and sleep for 1 second. The next part is sending the data. So we're getting all the 5 slot variables and we're making a loop. We're putting the slot state into array or a list, and data.append. So we append each slot state to this list. So slot 1, slot 2, slot 3, slot 4, slot 5. And then we send this all data through the library of rasp underscore I2C underscore photon dot trial data. And we're going to look at this in different video. That is all about the car park slots code.
The next part of my project is particle photon. Particle photon will be responsible for all the cloud part of my project. The avoidance sensors in the floor in the car park will send the data into Raspberry Pi. Then Raspberry Pi send all this data into particle photon. Particle photon will use particle.publish to publish this data. I created channels in ThinkSpeak that listening to this published data. So each car slot has its own channel that's showing if there is a car available in this car slot or not. Another channel is showing the car parked in the car park. So it shows the capacity and the busy period for the car park during the period. Another channel is show availability. So how many cars is available during the period for the car park owner.
This video is about how the data is flowing through in the publish area of Particle Photon Cloud. So as you can see here, it's coming from the Particle Photon to the cloud. So with each state 1, state 2, state 3, state 4, state 5, and then parked car slots and available, as you can see. So if we look here, slot 1 is 1, which means the park is the car is parked there. Slot 2 is 0, which means like there is no park in this area. Slot 3 is 1, which means like there is car there. Slot 4 is 1, which means like there is car. Slot 5 is empty for 0. So we have 3 cars parked, and we have available of 5 slots as total. So sorry, we have 5 slots, so the available is 2 spaces. If we look at the variable here, we can get the state of slot 5, which is 0, and which means like there is no cars there. And if we click on get for slot 4, we can get 1, which means like there is a car parked in slot number 4. Here we're going to talk about the integration between Particle Photon and ThingSpeak. On Particle Photon Cloud website, I'm going to add a new webhook for each of the car slots, and parked car and available. I have just created slot 1 and slot 2 because on ThingSpeak I was just able to do 4 channels, so I put parked cars, slot 1, slot 2, and available. So if we go to any of these webhooks, if I click on one of them, now the event name is called parked cars, and then doing an API request, and I put the API key which I'm getting from the ThingSpeak. So if we go to the ThingSpeak and channel, you can get your API, and then field 1 is particle underscore event underscore value, and then we save it as it is, and then the data is going to send across to ThingSpeak. And as you can see, it was successful through time to go to ThingSpeak, and on ThingSpeak it's just showing the chart of the numbers that's flowing through from Particle Photon Cloud to ThingSpeak. This video is about ThingSpeak. I was able to do maximum of 4 channels, unfortunately, so I use slot 1 state, slot 2 state, parked cars, and available in order to show or demonstrate how it's working. So if I go to any of these channels, this data coming from the cloud. So what's happening, ThingSpeak is actually listening to any functions that is published on the cloud for Particle Photon, and then it's graphed here. So slot 1 state, as you can see here, it's updating. So because I haven't like take any car off the slot or putting any other car in, so it's always 1. This will be very helpful for the business to know how many cars are on each car slot. And if I show you the parked cars, that is the total cars that is parked in the car park. So we have 3 cars parked there. Also, I haven't changed the number of cars, unfortunately, sorry about that. This will help the owner of the car park to know how many cars is parked and for how long, and the busy time, peak hours, all these kind of things. And available, it will show how many slots available and during which time over the period. I hope this gives an idea about how we can use ThingSpeak with Particle Photon, of listening to the published functions of Particle Photon on the cloud through ThingSpeak.
As you can see, the LCD screen and the Particle Photon is using I2C. Each one has its own address. The green wire from LCD and the green wire from Particle Photon is connected to a green wire to Raspberry Pi for the data, and the blue wire from LCD is connected to the blue wire from the Particle Photon for the clock, and the ground also is connected. So the Raspberry Pi can talk to LCD to its own address, and the Raspberry Pi is talking to the Particle Photon by its own address. Let's go to the next step.
Now let us look at the code for the I2C on the Raspberry Pi side. So we are importing SMBus and importing time library. We make an object called bus as smbus.smbus. We declare a variable called address. This is address of particle photon that we need to talk to through the I2C. How we get this address? If we go to the terminal and then we put down sudo space I2C detect space -y space 1 and click enter, that will show you all the I2C connections to the Raspberry Pi. So as you can see here, I have two things that is now connected on number 5 and number 27. The 05 is the particle photon that is connected with the Raspberry Pi, and 27 is the LCD that is connected on this address. I'm using two functions, write data and read data. On write data, I'm going to use the bus.write_I2C_block data, and then it's going to talk to the address of the particle photon and send the value which coming from the parking.py before, and then we sleep for 1 second. For the read data, I'm going to use bus.read_byte. It will call this function to this address of particle photon and we'll get it to number and then return that number to here. I'm going to describe the I2C on photon on different video. Now we're going to look at the particle photon I2C part code. First, we are including wire.h, that is the library I'm going to use. And then we define the slave address with the particle photon address as 0x05. We make integer number equal to 0 and make a list of my data of 8 integers. We declaring each slot state with 0, and then we declare parked cars at 0, declare slots as integer as 5, and declare a variable as slots minus parked cars. First, we making the setup. So the setup, inside the setup, we're going to begin the wire library with the slave address. And then on receive, we're going to call the function of receive data, which we're going to define in a second. And on request, we're going to do the or call the send data function, which we'll describe in a second. And particle.variable, we make a two variable. I will talk about these two variables later on. We declaring a variable with particle photon, which you can access online on the cloud, slot 4 state and slot 5 state, with the slot 4 state which coming from here. And then we looping. In the loop, we making a delay, and then convert data. We make another delay, and then we publish the data. So on receive data, we're going to make a loop. So while wire.available, we're going through all the data that are coming, and then wire.read, once it's read any data, we put it into the number, which we declared before as integer, and then we put this data inside the my data list. With send data, we're going to send back the first integer that is in my data just to confirm that it has been received. In convert data function, we're putting each of the integers that is coming into the slot state. So the first data that has come, I'm going to put it in the first slot state. The second data, I put it to second slot state, etc. And then the parked cars, it's just the addition of all these states because it's either 0 or 1. And as we know, the slots are 5, so we can calculate the available by deducting the slots minus parked cars. The published data, I'm going to use particle.publish, and then that is what is published is slot 1 state, and taking the slot state, change it to string, and then publish it like that. and delay between each state. Also, the parked cars is published to a string, and then slots and available. So on the website, we're going to get all this state into the cloud. I hope this gives an idea about the slave part of the I2C, which is the particle photon.
This video is to demonstrate IFTTT. I create a new function in IFTTT. So if we get a slot 5 state value as 1, then it sends an email to my student email. As you can see here, and if I go to the option of this one, so if the slot number 5 state on the MZ photon that is coming from the photon, if it's equal to 1, then it sends an email here. If we go out, that is on now. This video is a practical demonstration on IFTTT. As you can see here, my function on IFTTT is on. It says if slot number 5 is changed to 1, it sends an email to my personal or student email. As you can see here, slot number 5, which is the last one here, is empty, with green LED is on and red LED is off, and my email has nothing with IFTTT at the moment. So if a car comes and parks in this slot, the green has been changed to red, and if I went to the particle photon website, when the data is coming through, as you can see, the slot states coming, and slot number 5 has now become 1. If I went to the email, you will find an email has been received for slot number 5, and if we read it, it says MZ photon reports that slot number 5 is now 1. I wish this demonstrates the practical use of IFTTT. Thank you. We are going to move to the next part of my project. This part of my project, I'm going to talk about Blink application. I'm using Blink application in order to show the car slot and its availability. I have, as you can see here, I have 5 LEDs which show each car slot and if it's available or not. If it turn off like the first one, it's available. If it's turned on like the second one, it's not available. The button beside it is just for reserving this car slot, and we're going to talk about the next one. The bottom 2 buttons is entry and exit to control the gates in entry or gate on exit. As you can see in the back here, the 4 car slots are not available and the first one is available. So if I move back and put this car to the first car slot, the LED is becoming on, which means this car slot is not available. If I move it out, the LED is turned off to show it's available now. So if the person who is using this application wants to reserve this car slot for someone, he can come to the second button here and click on it like that, and this will turn the LED on the top part from green to red, even there is no car is parked there. That is because we reserve this car slot. And once the man is parked his car and he moved out of the car park, it will turn green again to show that is now available. The next part, I'm going to talk about the entry and exit. So going down to the gate, if I click the entry button, this will open the gate and close it back again. And if I press it and keep pressing, This will open the gate. It will not release it until I take my finger off. Thank you.